All right, cool. Again, thanks everybody for coming and hanging out. I expect this one to be pretty low in attendance. Everyone's still on vacation, like you should be and like I should be as well. But since we're here, let's just go ahead and close out the week with some really cool lab stuff. And so with that, I again, precursor to this, I don't have a lot of slides on this. I wanted to make it just kind of like last month's was. It was more interactive and demo driven. I work in sales, and so I spend enough time in PowerPoint. I wanted to take a break for just a little bit. So I got a few slides. We'll just kind of power through them because it'll help kind of at least lay the ground as to the technology and provide a little bit of context as to how all these things play together with each other. All right, with that, let me see here, we go. Looks good, that looks good. All right, so this month, again, thanks everybody for coming and hanging out. I'm gonna keep on adding my friends into the meeting. This one is gonna be a little bit different than our past sessions. It's focused on building network virtualization labs, and the context is quite different as opposed to like previous sessions where we talk about Ansible, we talk about Python, we talk about network source of truth and such. But I feel like this is such a critical aspect of building automation that it warrants its own topic. And right now is kind of a really interesting time as well for network virtualization, that it's worth just kind of digging into seeing some of the new things that are happening in this space. So that's what I'm hoping to do. As always, these sessions, please feel free to interrupt at any time. I spend a lot of time in this virtualization space, and so if there's any questions that you might have either on containers or virtual machines, or if you'd like to know kind of the inner workings, please feel free to sound off. This is really fun stuff, at least for it is for me. All right, so we're going to cover, again, just really quick some slides here. I want to talk about why even consider a network virtualization lab when the context that we have these workshops is around network automation. I want to showcase like kind of the two, I don't want to say competing technologies because that's not really fair, but the two primary ways of building network virtualization labs. And one of them is brand new. It didn't exist a couple of years ago. And so that's the container side of things. And then everything else that we're going to be doing today, again, it's just going to be demo driven. We're going to show you how to build network topologies with all these solutions. You don't have to absorb all of it. If one of them just really resonates with you, fine, perfect. Block out everything else that I talk about today. But hopefully you can find a solution that kind of makes sense for you. We'll be spending more time with a couple of solutions than others, just because I think that I'm pretty opinionated in this one, that I feel like some of the technologies are significantly better than some of the others that you'll see out there. Hi, Brian. Thanks for advertising that you're here. Good to see you, brother. All right. I also see Andre's here. Hey, Andre. Thanks for joining. Hope that Air Force is treating you well. So why would we even consider building a network virtualization lab for when the context is in network automation? Well, I got a few items here. Some of these resonated really strongly with me. The first one is that the lab's going to provide like a safe space, a place for you to test your automation against, and so that you can have a high level of confidence whenever you go into a change control that your automation is rock solid. And in that same spirit, happily employed engineers typically don't develop their automation against production environments. Please don't do that. You're going to give automation a really bad name. So please, if you want to keep your LinkedIn If you don't want to be updating LinkedIn, you don't want to be updating your resumes, please consider an automation environment like a virtualization lab as your primary place to build all of your automation against. Now, another really, really great thing about network virtualization technologies is that most of them are either completely free or open source. There are a couple of paid solutions, and actually one of them that I'll be spending a lot of time with today does have a paid solution. But if you're just looking to kind of get off the ground and running, there's a lot of really great options for you. Also, in 2021, finally, most of the vendors have a pretty good virtualization product that they offer, and many of them will actually offer it for free as well, because they recognize the need for labbing these environments as well. Everyone is a beneficiary of that. So there's two main themes of technologies that we have to help us build these network virtualization labs, and we'll touch a little bit on this. And again, if there's anything that you'd like a little bit more info on, please sound off. And there is a chat as well. The two main competing technology, or I keep saying competing, but it's not really fair. The two classifications I would put things in is in the virtual machine camp and the containerization camp. And just to give you a real quick high-level differentiation between the two, virtual machines are obviously what we've done in the enterprise space and in the cloud space as well for the last 20 years now. So virtualization is a very, very popular technology. It helped us squeeze all the juice out of a server. Whereas before, if you wanted to deploy an application, you'd buy multiple servers to host multiple aspects of that application. And if that server had some kind of leftover resources, too bad. That server was dedicated to that application, whether it was like a database or some kind of web server or SolarWinds or something along those lines. Now, what virtualization brought was this thin layer of an operating system that we call a hypervisor. And on a hypervisor, you're allowed to build these isolated operating system environments, right? So you can spin up a virtual machine with Windows, virtual machine with Linux. You can even do virtualization with Mac, kind of. You can sometimes get away with it. But what's really interesting about the virtualization world is that, yes, it completely radicalized the way that the enterprise does data center environments, right? But each virtual machine itself is completely self-contained, meaning it has its own operating system with its own drivers, its own packages. It has a construct for virtualization for all the things that you would see on the physical side, right? So you allocate CPUs from the host machine to the various virtual machines, right? So you have virtual CPUs that are allocated to devices. You carve up your resources for your RAM in the same way. So you have virtual RAM, you have virtual hard disks, you have virtual network interfaces. So you're starting with this one server, and then you're divvying up all the workloads, or you're divvying up all the resources to the various workloads that you have on there. And that's really great. Again, it's an amazing technology. I love virtualization. I think it's fantastic. But there are some downfalls that really didn't kind of show. There were some things that we didn't know that sucked about virtualization until a better solution came along. And that better solution, I would call it, I think it's better, is containerization. So when you hear things like Docker, when you hear things like Kubernetes, et cetera, containers take a different approach than what virtualization did. With virtualization, again, the idea is you take a server and you make multiple small servers and you carve up all of your resources across those workloads. In container world, the idea is that the application, which by the way, is the end delivery of everything within the data center. It's the reason that we have a job is to provide these applications a way to communicate. What's interesting about containerization is that the method of deploying containers completely removes the construct of infrastructure, right? So when you deploy containerization, it is laser focused on that application code itself. So it will use a container runtime, again, running on another host operating machine. But instead of creating virtual machines and allocating 2 CPUs to this VM with 4 gigs of RAM, a 20 gig hard disk, and 4 network interfaces. I don't know why you would do that on a VM, but sometimes you might. So instead of going down and carving up resources like that, now the containers run in a safe space, I guess you would say, on the actual host machine itself. Now, what this allows you to do is, I mean, it's a real enabler for a lot of modern application architectures, because containers can actually have their resources scale up or scale down whenever they're managed by a container workload management system like Kubernetes. So again, imagine a server with, if we take like an example here, if I've got a server that's got 4 CPUs, like the actual server's just got 4 CPUs, 100 gigs of RAM, 100 gigs of hard disk. I'm just using even numbers. In the virtualization world, I would have to carve that up into my various virtual machines. If I allocated 2 CPUs and 20 gigs of hard disk and 20 gigs of RAM to a VM, if that VM actually doesn't need all of that, guess what? It's still allocated to that virtual machine, and you would not be able to allocate it to another. Now, there's some different kind of technologies for various parts of resources that you can kind of get away with, like thin provisioning a virtual machine. But for the most part, those resources have been accounted for, they've been allocated, and you cannot cross that boundary. Now, in the container world, the container is only worried about the application that it's running. So it has no construct to the CPUs, no construct to the to the RAM, no construct to the network interfaces. It just leverages what the host operating machine does, right? So you can have some serious scaling capabilities with containerization if your application is structured in that way. And by the way, one other facet of containers that you might hear a lot about is this construct around microservices. Just so that we can provide a little bit of clarity, this isn't relevant for our conversation today, but in case you're curious as to the microservices, the idea is that you take a big mega application and you break it into individual components, individual functions, and then you have containers dedicated to that specific function. And that allows those specific functions, again, to scale up and scale down as you see fit. So there's a whole lot of elasticity that you get with containers, but probably more important for our context for today, containers have just really unparalleled performance benefits over the virtualization. And when we look at the lab technologies and some of the differences, you'll start to see, oh, wow, there's quite a bit of difference here. All right, now, oh, sorry, this is just another way of representing some of the points that I was talking about. On the left, you have your virtualization, you got a host operating system, you got your hypervisor. This could be VMware's ESXi, this could be KVM. There's a lot of different ones that we'll talk about. But again, each workload, each application would have typically its own dedicated operating system. And within there, you have your own dedicated virtual network resources allocated. Whereas in the container world, you're just running the applications on the host machine in a safe, what we would call C groups, not important, but just know that it's kind of like an isolated place for applications to run. All right, so that was a real quick speed run on virtualization and containerization. By the way, both of those are entire careers. So spending 3 minutes covering them does not scratch the surface. There's a whole lot to it. But if you are interested in a little bit more details, again, please feel free to sound off. Now, on the network virtualization side, on the VM side of things, we have some really great network specific solutions out there that help us build these virtualization labs. The one that I'm going to be showcasing probably most today is EVE-NG. But another really popular one that's been around for a very long time is called GNS3. And Cisco also has their own that they call Cisco Modeling Labs, CML, which there used to be a consumer version of that called Cisco Viral. But I believe that they've discontinued that and they've just kind of merged it underneath one name. So that name is CML. Now, you do not have to use the network specific topology or virtualization products. You can actually build your own using some of the standard hypervisors that are out there available for you today. We'll cover some of these today, things like KVM, Hyper-V, ESXi. Vagrant is technically not a hypervisor. It's kind of it's an abstraction on top of hypervisors. So you could use Vagrant to manage KVM. You can use Vagrant to manage VirtualBox, some of the other ones out there as well. But again, you don't have to stay allocated towards a network specific topology or network specific technology for building virtualization labs. You can absolutely get away with using some of the more traditional mechanisms. And based on your environment, this might be the right path for you. If you don't really want to dip too deep into the virtualization world, but you have like a virtualization team, you might just say, hey, virtualization team, spin me up some of these firewalls, and then everybody will be hunky-dory. But all of these that I have listed here are extremely mature. Some of them have been around for decades, and they are all outstanding, every one of them. Now, on the containerization solutions, this is an emerging field. So we have native support for containers in both EVE-NG and GNS3. We'll take a peek at what that actually looks like. We also have a new technology, or I'm sorry, a new solution that came out recently called Container Lab from our friends over at Nokia. And we'll be definitely taking a peek at this as well. I've been able to get such amazing resource allocation for these for the container-based network topology solutions. I've got, like, think of it like a small Raspberry Pi. I can spin up dozens of network devices on a single underpowered network appliance just by leveraging the construct of containerization. So there are some pitfalls, there are some limitations that you need to kind of be aware of. Again, not having dedicated virtual NICs, not having dedicated CPU and RAM. While the latter two don't really make that much of an impact, just know that there are some limitations that you have in containerization, and not all the network vendors are there with containerization. It's significantly easier to virtualize a physical appliance like a firewall or router or switch. By the way, that's not a trivial task, but it's significantly easier to do that than to actually deconstruct your network operating system into containers. But that's where we are today. And you'll see vendors like Juniper leading the charge with some of the containerization with the CRPD, which we'll be spending a lot of time with, which is the containerized instance of the routing protocol. I'm sorry, the routing daemon on Junos. You'll also see the containerized SRX firewalls as well. And I'm sure there are other network vendors out there that are starting to come out with containerization solutions as well. But we'll definitely be playing with these because I think they're the world. I think they're just so cool. All right. And again, you don't have to spend any time with the 3 container solutions that I mentioned. If you would like, you can actually roll your own, right? So you can just say, hey, I just want to roll my own using Docker. That's perfectly fine. We'll show you how to do that today. If you want to use HashiCorp Nomad, which is an amazing alternative to Kubernetes, hey, that's perfectly fine as well. If you want to use Kubernetes, good on you. That's a pretty difficult technology to master if you're not in that, if you don't live in that space, or if you want to even use your OpenStack environment to run containers, you can absolutely do that. So that's basically the pretext for today's conversation. Everything else we're going to be doing is going to be heavily driven through demonstrations. But again, I just want to let you know that there's really two technologies that will enable you to build these network virtualization labs to test your automation. One is virtualization, the other is containerization. And within both of those pillars, there are network specific tools out there to help you get up and running, but you don't have to use them if you don't want to. You can absolutely use the actual product itself and have really no impact as far as performance goes. All right, so down with the PowerPoint. We've made it this far. The very first one I want to talk about today is KVM. And there's a reason I want to talk about the KVM, because it's really the backbone of all the other, or many of the other technologies that we'll talk about. So KVM is, you might hear people say QEMU, QEMU, or they might say KVM. They're technically separate technologies themselves, but they kind of form together like Voltron to make a really amazing open source virtualization that runs exclusively on Linux. So what I'm going to be showing you today is how to get off the ground running with KVM. I'm not going to be doing installs for any of these because honestly, some of the installs take way too long and it's not really exciting. We're going to be looking at mature environments for each of these. But with KVM, just know that it is Linux specific. You're not going to be running KVM on Mac. You're not going to be running KVM on Windows. There are parts of the KVM solution that are expecting Linux things to be their Linux drivers, Linux paths, etc. Now, I'm going to be showing how to use, how to build virtual machines using KVM from the command line. But you should also know that if you have a Linux server with a graphical user desktop, or if you're just using like Ubuntu on the desktop, there is a GUI client that you can actually use as well to spin up some of these virtualization products. Now, the very best thing for you to do whenever you're in a KVM environment, honestly, is to elevate your privileges to root. There are some aspects of KVM that they expect root level permissions. And sometimes I've just noticed that even if you elevate your privileges with sudo, sometimes you can run into some hurdles with certain commands. And so what I always do whenever I get into a KVM environment, I try to escalate up to a root user so I don't run into those specific problems. Now, KVM will stall all of its goodies within this directory called var lib libvirt. So think of, when I say libvirt, think of a library for virtualization. And if I take a peek into my directory here for libvirt, I can see that I've got a couple of directories. Some of them are empty, and that's perfectly fine. One that just handles DNS stuff. Don't worry about anything in that directory. The one that I really want you to focus on is the images directory. So this is the default location that KVM is going to look for whenever you're trying to instantiate some kind of a virtual disk environment. Now, all of the directories that are nested underneath the images, I've actually created those myself. The directory, whenever you install KVM for the first time, it's going to be completely empty. It's a barren wasteland. And so what I like to do is I like to create a golden image directory. This is a place where I will put the default image for any kind of network device that I'm working with. In my case, let's take a look at that images directory here. I've got I've got one virtual disk image inside of the Golden directory, and that is a Juniper Virtual SRX. Now, what I do whenever I want to build a new virtualization or a new VM, what I'll do is I'll actually create a new directory. Let me say images VSRX3, and then I'll copy the image from my Golden directory into my directory for the virtual SRX, right? Oops, let me make sure I specify my image itself. There we go. And so again, I have this Golden image directory that I build just because whenever I build a new virtual machine, I need to copy the source from somewhere. And none of my virtual machines will actually reference the Golden machine. They'll actually reference the disk within their safe space. Now, what's interesting to know is that with KVM, everything is XML. It's like Junos, right? You can run certain commands, but at the end of the day, it ultimately translates into XML. And that's how some of the definitions for resources, remember, we have to create like virtual networks, virtual disks, all those types of things. But the actual definition of the VM is going to come in and be packaged inside of an XML file. Let me show you what that looks like. It might look a little intimidating, so hold on. Hopefully I'm not going to scare you off here. I can type in a command to interact with KVM. It's called virsh or VIRSH. I'm guessing that just means virtual shell or VM shell or whatever you want to look at it. So in this case, I'm saying virsh list. This is going to list out which virtual machines are currently running. If I had some virtual machines that had been provisioned but are decommissioned or they're just powered off, I can type in virsh -- alt and it'll list both running and powered off virtual machines. But remember when I said everything comes back into this XML definition? Let me show you what that actually looks like. If I say virsh dump XML, and we'll pick on virtual SRX1 here, what you're going to get out to the screen, this is going to dump out the XML for the virtual machine, right? So you see, yes, this is XML, but you'll also see like how much memory is being utilized by this, what kind of architecture is this running, AMD, is this running ARM based, how does when the virtual machine boots up, does it pick the CD-ROM first or does it pick the disk? If there's a disk, where is the disk located? What types of physical network adapters? Remember, all those virtual resources that we talked about are ultimately defined in this, what they call a domain file. Now, there is no way in hell that I'm personally going to write this. I will never do that. There's way too much information and I will get it wrong. Things like MAC addresses and all these types of virtual network ports. So instead of actually defining an XML file, we're given, again, the shell that will help us interact with the KVM to actually automatically build this out for us. And I'll give you an example of what that looks like here. If I dig into my scripts directory and I'll pick on this shell right here, this is just a shell script that I have that will actually build that big XML file that I was just showing you and also power on the virtual machine. Now there's some echo commands that I just have here just for my use so that I can actually see them. I have a little bit of understanding as to what's happening. This is not a complicated shell script by any stretch, but this is the command that kind of kicks everything off, this virt-install. Whenever you type virt-install, there's a set of parameters that the KVM is expecting you to pass, like what's the name of the device, how much RAM, how many CPUs, where's its disk, how many network ports, what driver are those network interfaces, are they E1000, are they VirtIO, all those stuff. Are we going to have a VNC console or is this going to be a serial based connection? All those types of things that KVM needs to know. And once you pass all these parameters, KVM is going to build that big XML file that I just showed you based on what you pass it here. And then it'll instantiate the virtual machine itself. So in our case, we just created a, let me see, we put that in images, virtual SRX3. Okay, so there's the name of my disk. I'm actually going to rename that disk to something that's a little bit more consumable than the default. So we're going to say move the name of this this disk path, and I'm going to move it to a new file name. Now that's if you don't play in the Linux space, some of this might be kind of confusing, especially this operation. To rename a file in Linux, you move it from its original file name to a new file name. So in my case, I'm renaming this long Junos file name and path to just hda.qcal2. QCal2 is the virtual disk image type. You don't need to know too much about that. Just know that there can be a virtual image disk type of IMG or RAW or QCal or QCal2. QCal2 in the KVM world is easily the most accessible one. It's the one that's out there most often. Now that I've got my image and it's in its own dedicated directory, what I'm going to do now is let's copy this script that I have here. Say copy scripts and then the domain file for virtual SRX1. We'll go ahead and create another one for virtual SRX3.shell. Now, before I kick this off, I gotta point some things out. In this case, when we look at virtual SRX1, what is interesting for us is that we have 5 different network interfaces. So in my case, if we look back at the virtual machines that are actually running on this device right now, I have 2 virtual machines, virtual machine or VSRX1 and VSRX2. Now, if I want to jump into those devices, I can either telnet to their management port, SSH to the management port, but KVM also provides you the capability of getting into the actual console from the command line from your Linux host. So the way you would do that is you would say virsh console and then the name of the virtual machine itself. So in this case, we're going to say virtual SRX1. And when I hit enter, I can see I'm inside of this virtual SRX. The reason why I wanted to show this is that these virtual SRX devices are actually in a cluster with each other. So that's some of the reason why I had 5 network interfaces. When you bundle or group firewall appliances together, there's usually a dedicated port for communication between the two so that they can see each other, have heartbeats and those types of communication. There's usually another interface dedicated for a fabric interface to allow traffic to go through one VM and maybe out another interface on another VM. But in this case, I've got 2 firewalls that are in a cluster together. Now, to exit out of this console, this is really important because you will forget. The terminal will tell you that the escape key or the escape character is the Shift-6 and the close brackets. Now, I never do that because I never get it right, because as a genius, one day I bought a keyboard that doesn't have any keys on it. Well, it doesn't have any letters on it. You have to know based on muscle memory. So I never remember how to hit Shift F6 without being able to look at my keyboard.
DOS keyboard?
Yes, that's exactly.
I love it. I love that keyboard.
I love it too, but holy moly, it makes complex passwords a nightmare for me. So what I do instead is I hold down Control and I press the close bracket. And so that will jump me out of the console session. Now, again, the reason why I'm mentioning this is that I have these dedicated virtual network ports to handle things like cluster and that fabric port that I talked about between the 2 virtual SRXs. If I was to instantiate this 3rd virtual SRX with those same network interfaces, we might have some communication issues as the virtual SRXs are not expecting a 3rd virtual SRX to come into the cluster. It might cause some problems for us. So the reason why I'm mentioning this again is that if you look into my scripts directory, yes, I had the script to actually do all the virt install stuff, and we copied from a previous, but I also have some XML files here that will actually define virtual networks for us, right? So let's take a peek at some of those here. I'm gonna say cat scripts network LAN 1.xml. Yes, it's all XML still at the end of the day. And you can see here, I'm defining a virtual network, right? This is not like a VLAN that lives on, my actual physical LAN. This is all on the software switch layer within my host itself. So I've got a LAN, I've got an IP address, I've turned on spanning tree protocol. We can actually hand out DHCP reservations to any of the virtual machines within this. But what I need to do now is after I've defined this, let's see, I am not using LAN 2 anywhere. Let me get into my scripts for our new virtual SRX 3 here. And let me remove the control interface and the fabric interface. Again, I don't want it conflicting with my chassis cluster that I have here. And I'm gonna change this inside to be LAN, say model, I'm gonna say LAN 1. And we'll go ahead and we'll also include, and say Shift V, and we'll go ahead and include LAN 2. So basically, I'm gonna have my first interface is gonna be on a network called default. This is automatically provisioned by KVM. That's gonna be for my management interface. I also have my first physical interface, or my first revenue port is gonna be the outside, which is my WAN. That's fine. And then I'll have LAN 1 and LAN 2 come up on ports 1 and 2 respectively. Let's also update the name of my VM here to virtual SRX3 and make that also virtual SRX3. And let's make sure we pick the right disk as well. Right? So virtual SRX3. All right, good to go. Really important for my use case. I'm not going to be expecting a graphical user interface. You would use a graphical user interface if you're building like a Windows VM or a Linux VM, something that's expecting you to be able to see what you're doing. In our case, we don't need any of that silliness. So I will move back into my scripts folder now, and I'll just execute, I will say shell domain virtual SRX3. And so here's that echo. Now, this is interesting. Network 1, LAN 1 is not active. So let's take a peek here to see what I did wrong. And that's true. So I typed in virsh net-list. This shows me from KVM's perspective, what are all the virtual networks on my host? And I can see, hey, there's our control, there's the default, which was default, fabric inside and outside. So what I actually need to do now is I need to define LAN 1 into the KVM world. Yes, I've created an XML file, but I haven't actually instantiated that virtual network. So I'm going to say virsh net-define, and I'm going to point to my file of network. I think this network underscore LAN 1.xml. And it says LAN 1 is already defined. So let me try to destroy LAN 1 here. And LAN 1 is not active. Where is there's another one in here. Undefined. Let's try that. LAN 1 is undefined. And let me go back to redefine it. Okay, so now I've defined it. What happened there is that I was trying to be a good scout and prep for my meeting with you all today. I had actually already defined LAN 1, but this is a weird nuance you're going to run into in the KVM world, so I'm kind of glad we ran into it. You can define virtual resources like a VM or a network or a disk or something like that. There's a definition of it, but whenever you want it to go away, you have to not only use destroy to destroy the virtual construct, then you have to undefine the virtual construct. So like if you spun up a virtual machine and you had it up and running and you wanted to like start over from scratch, you would first destroy the virtual machine by saying virsh You would say DOM, or is it destroyed? You would destroy the name of that virtual machine, and then you would undefine it. It's real kind of weird. It's a hurdle that you will run into. But now I've got the LAN 1. Let's see if we have to do that for LAN 2 as well. It doesn't look like I need to. Let's do net-define and then point to my file. Again, this time I'm saying network LAN 2. All right, so now I've got some additional virtual network ports assigned. If we jump back into here and I say virsh net list, I don't see them listed out here. Let's cross our fingers that this is going to work. Domain virtual SRX3 shell. Then it looks like LAN 1's not active. So, oh, it's not enough to define it. You also have to enable it. Sorry about that. So we're going to say net start LAN 1. And it's already used by an interface. Net start LAN 2. And there's a net, like there's an auto start LAN 2 and a net auto start LAN 1. Now, you can use some of the traditional Linux commands as well to check your bridges. So bridge control show will also show the virtual interfaces and any physical VM interfaces that are assigned onto those. So in this case, I can see all those goodies, or if you want, you can do IP link show as well, and you can get the full shebang. In my case, just to make this real quick and to the point, I'm going to undefine. I'm going to remove the LAN 1 since it looks like I messed something up going into this, and we'll just go ahead and run that script again here. There we go. Okay, so this is going to again, this is now going to boot up that virtual machine. So this is actually pulling down, or actually, this is referencing that virtual disk. Remember, we copied the golden image that we had pulled down from juniper.net. When we put it in a directory, now we're booting up that disk and it's going to go through the process. And if you remember, the way to escape out of KVM is to hold control and hit the square brackets. Okay, so that's going to go ahead and run in the background. At any point, we can check in on the status of that by say virsh console and VSRX3. And that's KVM in a nutshell. Again, there is a graphical user interface that's available on Linux. There was someone tried to make it work for Mac and Windows, at least the client side of things. I've never found it to be very good. So I can't really recommend ever looking down that path. Now, the reason I wanted to start with KVM first is because the network specific virtualization products that we talked about, things like Eve and GNS3, they all use KVM underneath the sheets. Even if you remember, I said that you can't run KVM on Windows, but if you use a product like GNS3, which we're showcasing now, what actually GNS3 will do is it will spin up a KVM virtual machine in the background. So this is GNS3. This is an open source network topology solution. It's pretty excellent. It's been around for quite some time. Its primary focus in life for its early years was like almost exclusively Cisco-based devices. And I should caution you, really sketchy iterations of Cisco devices, like Cisco didn't want you to run these VMs. And so there's IOU, which is iOS on Unix. That is only for Cisco employees, and if you have access to it, then you are breaking their rules and regulations, and you can get in serious trouble for that. So I'd highly encourage you to never do that. However, within the last few years, Cisco has been producing some virtual images themselves. They produced the virtual ASA, the CSRV, even the NXOS had a virtual machine for a while. A little problematic, but that's a whole other conversation. But the idea here is that you spin up this GUI and then you have it connect to a KVM machine in the background. Now, In the GNS3 world, they call it the GNS3 server. That's fine. They can call it whatever it is, but you and I know that it's just KVM in the background. In my case, I have a KVM or a GNS3 virtual machine running as a VM inside of my VMware environment. And I'm not going to show you the VMware environment because that's another part of today's conversation. We'll get to that. But once you have connected the dots and the client on your workstation is connected to the GNS3 VM in the background, you can look for a search and download what they call GNS3 appliances, which at the end of the day is going to be a KVM domain file, just like what we looked at. Now they're packaged and showcased a little bit differently in GNS3, but at the end of the day, again, it's using KVM in the background. So that's actually where all the instructions get translated to. In my case, I have another virtual SRX. In this case, I'm going to go ahead and I've imported the virtual SRX image, and it's now accessible for me. What I need to do is just click and drag to a topology, or I actually need to create a new Blink project. We're going to call this August for some reason, because August is almost here. I'm going to drag it onto the topology, and I'm going to drag another one on the topology. And so I've got my two virtual firewalls here. If I want to make a connection, I move away from the device panel and I click on this add a link. Once you see it, once I clicked it, the icon changes. It shows the little X mark. And here I can click on the device and it'll present to me which interfaces are available on here. So I'll pick gigabit 0. And on this one, we have gigabit 0. Now you can also do serial connections in GNS3, although I don't see where that is any longer. There definitely used to be serial connections available on here. And that was a really big appealing one for those of us that were doing CCIE studies like 10 years ago that needed to do some frame relay and stuff. Oh heavens, I don't miss that stuff. But again, we drag the devices to the topology. We use the add a link functionality to build the connection in between them. But you can see in the right-hand side some insights into our environment. I see that I've got two firewalls. Let's go ahead and I'm going to rename this one as Virtual SRX 1. And look right here, like you can see it right in behind the scenes. The QEMU binary. Remember what I said, KVM and QEMU, they're technically separate, but they form together. KVM basically gives QEMU some direct access into some of the host operating system, not drivers, but like the physical resources. So KVM sprinkled on top of QEMU is what we affectionately call KVM. But here you can see that it's actually calling the QEMU binary. That's going to run on the virtual machine in the background. And console type, you can select Telnet or VNC or maybe Spice if you're doing a Linux, like Red Hat supports Spice as well. And you can see some basic parameters of this. I'm not using a boot up ISO. I'm actually using the disk that I downloaded from Junos or from juniper.net. Really interesting, if you need to change the network driver for any reason, you can click this drop down menu and you can select what network driver. Just so you know, the most common ones that you'll run into are E1000 and VMX Net 3 and VirtIO. So E1000, that's an Intel driver. It's usually found in a lot of legacy virtual machines, still pretty darn good at getting packets on the wire. VirtIO is coming from KVM World, and VMX Net 3 is coming from the VMware side of things. So I'm going to leave the defaults here, click OK, and I'm going to right click now and say start. I'm going to do the same thing on this side. We'll just go ahead and rename this Virtual SRX2. Again, I can tweak the resource allocations. I probably should tweak my resource allocations because the Virtual SRX is expecting at least 2 virtual CPUs, but I think I can get away with it. Let's go ahead let's go ahead and start this one up as well. But you can see my poor virtual machine that's running here with some pretty small resources is already kind of saying, hey, hey buddy, slow down. You're kind of using all that you have to run this. But let's go ahead and right click, and I'm going to say console. And this is another really great feature of GNS3, is that you have a lot of flexibility as to what kind of console to open up. It can open up like iTerm on Mac, or Secure CRT, or in this case, I'm using the basic Mac terminal itself. But here you can see the virtual machine is coming online and it's booting. This is a vanilla virtual disk for the virtual SRX. There's quite a bit of things that happen when that virtual disk boots up for the first time. So I'm going to let it go through its thing, but that's essentially the construct behind GNS3. You can include you can connect the virtual world into your physical LAN as well. They have this construct around a cloud interface that you can actually configure to act as like a bridge to the physical LAN as well. And if you did that, you would then be able to like connect the management of this interface into the cloud. And then you could be able to access your virtualization lab, like with Ansible, from either some other centralized server, or in this case, maybe it's your own machine running Ansible or Python. But again, a really great way of getting up and off the ground and running GNS3. It's not going away anytime soon. It's still really easy. It's quite intuitive to get off the ground and running with in comparison to some of the other products out there. However, I will say I've done a lot of speed tests, not really speed tests, but like resource allocation tests. And GNS3 just doesn't squeeze the virtual machine for resources like what I see with EVE-NG. So if you start to see stuff like this, that your virtual machines are kind of consuming all of your host operating system's resources, the CPU and RAM, you might want to start looking at some of the other solutions out there to see if you can't get something that allows you to run with a little bit more bang for your buck. Now, in some cases, you're just like testing a Python script, or you're testing an Ansible playbook against a single device just because you want to see how it works and whether or not it breaks anything. But and therefore you don't need a full topology. You don't need to build like OSPF adjacencies and BGP adjacencies. You're just trying to figure out whether or not your script is going to be able to commit its configuration successfully. In that case, then hey, if you stick with the small lab, GNS3 is a fantastic product for that. However, if you wanted to, again, if you want to build big topologies, if you're doing some kind of complex security firewalling, or maybe an MPLS network, or maybe a data center, you're probably going to hit some hurdles as far as resource allocation goes. Let's see. Andre says, so you set up your network like a virtual switch port group, like in VMware. Yeah, absolutely. And looking at the timestamp, I'm about 17 minutes late to that question. So I'm assuming it was regarding the KVM, but yes, absolutely. You would define your virtual switch or your virtual network just like you would in VMware. And thank you for that segue, because now we're going to talk about VMware itself. Now, in my case, I have a VMware environment in my house. I've got a few different servers on here, and I'm managing them through VMware's management product called vCenter. Now, if you're interested in VMware, but you don't got the thousands of dollars that it's necessary, VMware does have an amazing program for you called VMUG or VMUG. I don't know exactly how they call it, but the idea is it's an annual subscription, and you get access to like everything that VMware does for like 100, maybe $200. I don't remember which one it was, but so you'll get like ESXi, you'll get vCenter, you'll get NSX, you'll get a workstation, VMware Workstation or VMware Fusion. So if you're already paying a subscription, you're honestly paying a subscription for things like Workstation and Fusion. technically that's not the case, but it kind of really is at the end of the day. This is probably a better solution for you to go down to help you save a little bit of money, and you get access to some of the cool resources that they have here. And so in my case, I've got a few physical machines, one that's just running basically home resources like DNS and DHCP in my home lab, some NTP, and yeah, some redundancy, some Libre NMS for doing some basic network monitoring. So classical SNMP type of stuff, right? But the thing that's nice about VMware, well, there's several things. I'm a very, very, very big fan of VMware. I think that their hypervisor ESXi is, simply put, fantastic. It's simple to manage. And when you add on the vCenter, you sprinkle the management to be driven through vCenter, then you can manage multiple different hosts, and you can do some really complicated networking through virtual distribution switches or NSX. There's some really great things that you can do here. Now, in my case, I'm just focusing in on network virtualization labs. So let's just go ahead and take a peek at this server right here that I've got running. We'll just ignore all of my power warnings because I don't need to worry about that. Now, in this case, you can see I have several virtual machines already lined up for, in my case, my firewalls here. But if I wanted to, and there's our GNS3 virtual machine that was kind of pegged out. Here's the KVM machine that we started with on the Linux command line where we were talking about KVM. So I'm running virtual machines inside of virtual machines. A few years ago, that was a terrible thing to do. The performance was pretty abysmal, but the technology's gotten better both on the CPU architecture as well as the hypervisor layer. So it's not trash like it used to be. And in fact, probably the most common virtualization thing that you'll see for applications these days is they'll run something like Kubernetes, which again is its own virtualization construct. They'll run Kubernetes inside of a virtual machine. There's a lot of lifecycle management reasons as to why that's a really advantageous way of going about doing things. So in our case, what we would do is we would go to something like juniper.net, and I say like, hey, I want a router. And so we'll go to the support page, we'll go to all downloads, and in here I'll type in VMX evaluation, and we get a list of different disk image types based on the hypervisor. So if you wanted to do KVM, hey, there's the KVM. We'll be taking a peek at that one just in a second when we get to EVE-NG. But in our case, if we wanted to spin up on ESXi on VMware, I would just click on this tar.gz. We here at Juniper do offer evaluations for virtual MX, virtual SRX, virtual QFX, and we also have containerized solutions for the routing daemon and the containerized SRX as well. I would read all 21 pages, maybe not, click the agree and click proceed, and I would download the image. Now in my case, this is a big boy image, and a lot of virtual disks are, right? A lot of them are significantly larger than like a installation ISO. Like if you download Windows, well, that's a bad use case because Windows 10 VM is like 8 gigs itself. But like if you were to download Linux, typically they're within like the 700 meg range. But if you download a disk itself, then it's usually pretty big. In this case, it was like, I think it was what, 4 gigs, 4.6 gigs. But after that image is downloaded, you would unzip it just like you would with any file, and you'd be left with an OVA file. And what you would do in this case is you would right click on your host machine inside of VMware, and you would say, deploy an OVF template. And from here, you would select local files. And let's see if I can find any OVAs inside of here. Let me see if I've got any. I might sort by type. Maybe not. I might not have any OVAs, but here you would select the output files of your. Gosh, I've got a lot of files. You would select the output disk of your virtual machine, and VMware will give you kind of like a next step, saying, hey, do you agree to this license from Juniper? Which interfaces would you like to instantiate? And as soon as you're done, you would have your virtual machine and it would be powered off. Now, in my case, I've got a virtual machine here, virtual SRX 0. I'm going to go ahead and power that on by right-clicking on it and saying power on. You can see that I've got a bunch of network interfaces assigned. Again, one for out-of-band management, another for HA, fabric interface, a trunk interface, and then an uplink to go up my WAN. And I could do the same here for virtual SRX1 as well. Just power that bad boy on. Looks like my operations are failing. Oh, great. I'm moving things around. So I apologize. We're not going to see those things get up and running. Actually, I've got a template of that. So let's do that instead. I'm going to right click. I'm going to say new virtual machine. I'm going to say deploy from template and click next. And in my data center here, let's go ahead and look at some of the templates that I have in my templates directory. Here's one for virtual SRX running 20.21.code. And we'll just call this Juniper Virtual SRX number 5. And I can select the folder directory that this VM will go in. I'll call this one under network services. This will be under my firewalls directory here. And I can select what host I want to. Now, you can see here, I've got some compatibility issues. Let's take a peek at that. And it's going to say, hey, the virtual machine is referencing a network adapter that's on a distributed switch that's not available on this host. I'm going to say, thank you, that's good information, but go ahead and click next. And here I'm going to select which disk I want to install this VM to. Click the next button again. And I say I want to customize this virtual machine's hardware. And this is where I would go into the network ports. Remember, there were some missing network adapters or missing distributed switches. And I'm just going to say browse, go ahead and pick my out-of-band network, and then go ahead and we'll just put everything on that same local LAN. No big deal. We actually won't see the instantiation, but I just want you to see the actual provisioning process itself. Click next and finish. And like my clone operation failed because the source virtual machine is currently in maintenance mode. So this is just another reason why you don't move things before a big demonstration, because now everything is broken. But hopefully you get the gist of working inside of VMware. It's rather intuitive, point and click. You can upload files directly from your computer into the product itself. Everything supports templatizing. You can also do snapshots really easily in here. You can roll back virtual machines. You can do snapshots on running virtual machines, which will capture not only the disk itself, but will also capture the current RAM state. And so that when you roll back, it rolls back exactly to that state, which is really slick. So VMware's done quite a great job on here. One other thing that I want to talk about before I get into EVE-NG is Vagrant. So Vagrant is like I mentioned earlier, it's not a hypervisor itself. It's more of an abstraction, something that allows you to consume hypervisors without having to learn the hypervisor itself. It's made by one of my favorite companies in the world. That is HashiCorp. I think they just make amazing products. I can't spell it. HashiCorp Vagrant. And the install, again, I'm not going to show you the install steps because it's rather mundane, but it's super simple to get up and running with. This is a very, very mature product. There's not a whole lot of development going for it because it's pretty much rock solid at this point. But once you have Vagrant installed, you need to also have another hypervisor on your machine. So in my case, let's see, I'm hoping that I've got, I might not have another virtualization on this box. Let me see real quick here. What am I looking for? A VirtualBox. Okay, so VirtualBox is a hypervisor that can run inside of a desktop operating system. It's now owned by Oracle, and the product has not really seen any improvements since being acquired by Oracle. Not really too surprised to hear that, unfortunately. But the way that you interact with it is you would type in Vagrant, and let's see, Vagrant version here. Okay, I'm running 2.2.5. So to get off the ground and running with Vagrant, the best thing that you can do is go to Google and say Vagrant, and then say something like virtual QFX. Now at Juniper, we ship our virtual data center devices as Vagrant images. So if, for instance, if you wanted to get up and running with Juniper devices, but you didn't have a Juniper.net account, not many people know this, but this is a shortcut to getting your hands on some Juniper devices in an official capacity without having to have a dedicated login for it. So Vagrant has a website, they call it Vagrant, I think it's called Vagrant Up. Let's see, Vagrant Boxes, Vagrant Up. And then inside of here, let's see, that's documentation. That's not the droids I'm looking for. Let's see, Vagrant Box, Virtual QFX. And let's see, here we go. Here's the official Juniper release. So all you would need to do is create a file, a text file with the name of Vagrant file. And you would need to have, at the bare minimum, these 3 lines within that file. That's enough for Vagrant to identify what you're trying to run, reach out to the internet, pull down the image if it doesn't already exist on your computer, and then spin it up. Now, obviously, there's some things that aren't really there, like as far as like, you know, building complex network environments or whatever. We have a dedicated GitHub repository for all Vagrant devices for your use case. So if you want to do a full QFX, meaning a forwarding engine as well as a routing engine, and stitch them together, you can do that. Here's another topology that has a server. Here's one that has 4 QFXs together. There's also some lighter ones. If you're kind of short on resources, you can cut the forwarding engine virtual machine out. But what you would do is you would say, all right, let's click on this one. Here's the topology. Yeah, that looks right. We're going to have the virtual QFX routing engine. It's going to be connected to a server, a Linux server. And there's also going to be another connection to a forwarding engine virtual machine as well. So what you would do is you would open up the Vagrant file, and you would just click on like raw. And in this case, I'm going to click save. I'm going to save this to my desktop. This Vagrant file is a list of instructions as to everything needed to get this VM up and running. Now, the Vagrant file itself, if you just downloaded it with Control S like I did, you can see there's an extension that was put on it by my Mac because Mac thought it was being helpful when it was really being harmful. I'm going to remove that extension by saying move Vagrant file, and there we go. So if I look at my desktop directory, let's just say ls, there's a Vagrant file right here. So let me clear my screen. The only thing I need to do now to get up and ground and running is type in Vagrant up. And that's going to detect that I don't have the virtual QFX routing engine on my machine. It's also going to detect that I don't have the forwarding engine, and also detect that I don't have the Linux VM. So it's reaching out to the public internet, and it's downloading those virtual machines for me right now. And it's going to create all the networking that's necessary for getting this VM off the ground and running. Now, in my case, it looks like I messed up. Let me see here. Uh, looks like there's a problem with my version of VirtualBox. So probably should have done some kind of vetting out of this ahead of time, but hopefully you can see kind of the ease of use with Vagrant. Again, if you want to run virtual machines on your local computer, but you don't want to figure out how to use VirtualBox or something like a VMware product, then Vagrant is a really good way of doing this. Vagrant can also manage VMware hypervisors. So if you have Workstation on your computer, or if you have VMware Fusion on your computer, you can still use Vagrant, and Vagrant will orchestrate the VM instantiation. But you need to know there's a license you'll have to pay, because the VMware licenses that kind of functionality. So Vagrant has to pass the buck to you to pay for. I personally, I used to do that, but I ran into problems with versions and I ultimately stopped using Vagrant entirely. But there is an option as well to manage the VMware stuff as well. The next one I want to talk about is EVE-NG, and this is easily my favorite of them. Now I'm running EVE-NG as a virtual machine inside of my VMware environment. You can see it right here. Some things about EVE-NG that you should know. There is a community version of EVE-NG, which is like 2 dot something, version 2 dot something. And then there's a professional version of EVE-NG. And you might not be surprised to hear that the professional version actually costs money. And it's a significant amount of money, I think, when all the other solutions that we've showcased outside of VMware were all free and open source. The professional version of EVE cost about $120 after taxes, and it's a subscription, right? So you would pay that annually. That was also something I didn't know until stuff started to not work for me. But I personally feel that the professional version is absolutely worth it. Not only does it help the development of the product itself, but you can do some really amazing things with the pro version. The pro version right now is running 4.0.1. So obviously with the community back on 2 dot something, there's been a lot of things that have happened since then. And I honestly haven't kept up with the community version, but I do not feel like there's really any work being allocated into that. The EVE-NG, I think it's just 2 people that run this project. So support is pretty limited, but it has been pretty darn good. But for the most part, this is what is the de facto for network engineers to use in building network topologies. And I hope to show you why here. When I sign into the EVE, the thing that you should know is that EVE is going to run as a virtual machine or on a bare metal server, but the way that you interface with it is through a graphical user interface within your web browser. So right off the gate, I already love it because I don't have to download some kind of client on my local machine to be able to interface with EVE-NG. Another really great thing is that, holy moly, it can do some like almost any network device out there. If we look at some of the unprovisioned templates here, you can start to get a pretty good perception as to all the different types of virtual. Oh my goodness, Cisco's got a lot of products. Holy moly. Huawei, we can see all the Junipers in here as well. So pretty much if you're looking to do some kind of virtualization, you can pretty much be rest assured that EVE-NG is going to support it. The recent release for EVE actually has native support for 2 of Juniper's newest products, 128T for our SD-WAN. It was already a software solution itself, and Apstra, which is our data center inventory management product, intent-based networking. So again, like you can pretty much do anything inside of here. In addition to all the great selections that you have to choose from, they also have native support for Docker, which allows you to run containerized workloads on your network topology. And they have some really great ones pre-canned, like Kali Linux. Like if you live in the cybersecurity space, you like to do pen testing, etc., just to be able to drop in Kali Linux on any network topology is just fantastic. There's also dedicated containers for doing things like Wireshark. But let's talk about kind of like the general consensus of what it is to actually, Mufasa says EVE-NG is life, no lie. EVE-NG is great. I have had my frustrations with the product over the years, but it is pretty excellent where we stand today. The idea is that you create a folder directory. Have they fixed the network speeds? No, Zach, they have not. And I don't think they will. There's some complexity with how they're doing the networking behind the scenes to enable like hot link swapping between VMs. That's something that you can't do with QEMU and KVM, but surprise, EVE-NG is using KVM and QEMU underneath the sheets. Actually, it's just using QEMU, I believe, but you can't do that natively. So they've inserted like this, I guess it's like an open virtual switch layer, which every network interface for every device automatically connects to, and then they just handle like any kind of hot linking. It's kind of complicated, but I don't think EVE-NG will ever be a product where you want to perform like network speed tests or anything like that. You get pretty poor performance from a packets per second. And honestly, for me, that's totally fine. As long as I can get like control plane up between devices, hey, I'm all hunky-dory. Let's go ahead and create a new lab here. Sorry, Zach. I'm going to create a new lab, and I'm going to call this lab Zach, just because Zach's a little frustrated. You can see that you can get some pretty cool options just here within the setup. You can add descriptions. You can version control your lab. You can also use a satellite, right? So a satellite is like basically having an extra EVE-NG server running somewhere else within your environment, and you can allocate VMs to run, on this server, and then some to run over on this server. And Eve actually uses a technology called WireGuard to build a layer 2 VPN between the two hosts or the satellite machines, so that you can have layer 2 adjacency on different Eve servers. And this whole construct around clustering comes at no additional cost. If you purchase Pro, don't worry, you don't have to purchase additional Pro licenses for each server. But this is, there's also capabilities in here to do kind of like countdown timers. So if you're studying for your JNCIE security or your JNCIE service provider, and you just know that exam, the lab is going to eat you alive, you can build out a mock environment of what you think that lab will look like, and then you can start to set some timers so that you can start building up your speed run capabilities. I never really do anything other than set the name of my lab. So I'm just going to go ahead and click save. When I do so, I should be put into let's go ahead and open that up, a blank canvas topology. Now, if you don't mind having your eyeballs singed, you can turn on the light mode and you can run like this. And if you're into that kind of weird, I don't want to call you sadistic, but like if you like the pain and punishment of like a plain white canvas across your eyes, you can absolutely use that. I highly recommend either enabling the dark mode or installing a Chrome extension called Dark Reader, which will turn any browser into dark mode for you. But here we have a blank canvas. And so let's go ahead and start adding some devices onto my topology. I only have those that are within my Eve environment right now. I will show you how to add a new one here in a second by using the virtual MX that we had downloaded from Juniper website. In my case, I'm going to say, let me spin up we've been doing some firewalls, so let's spin up another firewall. And I'm going to add, let's say, 4 firewalls. I can select which image version. So if you have multiple version images, you can select from this drop-down menu. For the name and prefix, what I typically like to do is I like to leave a hyphen at the end, because EVE-NG is going to append a number to your VM at the end of it anyway. So I like to leave that little hyphen there. You can select the icon if you care about it. Here you can see some of the, I'm going to call them KVM resources. They're really QEMU resources. Here we can see some of the defaults are already provided for us, how many CPUs, how much RAM. If you have the juice in your machine, you can absolutely bump these up, say 8192 for 8 gigs of RAM. I want 8 physical network interfaces. You can also tweak what kind of CPU flags that you want KVM to run. Now, EVE-NG comes with pre-canned defaults for the virtual machines based on the virtual machines requirements. If you're playing in this space, like adjusting the flags that you send, then you should know what you're doing. But these are the same flags that you saw us throw whenever we were doing things from like virt install as well. Startup config is really interesting. The idea is exactly what it sounds like. If you have a pre-canned startup config, you can incorporate it inside of here. I'll show you how to do that in just in a second. Also, the satellite machines, if you have multiple Eve instances, you can pick which one that you want this to run with. Delay is a really, really important topic that I'll talk about in just in a second. Console, in our case, we're going to use Telnet. It could be RDP, it could be VNC, it's whatever makes sense for you. Go ahead and click save. That will add 4 new virtual appliances on my network topology. They will all be powered off. You can see a number was appended to the end of them. In order to build that network connectivity, you just hover your mouse over the actual device, select the orange, or wait for it to look like it's that orange color. Click and drag your mouse to another device, at which point you'll get a pop-up menu that'll say, all right, on virtual SRX1, which interface? In my case, it's going to be 000. On virtual SRX2, what do you want to connect it to? We'll pick that one as well. And then that will actually handle all the link connectivity in between those 2 virtual machines. So what we had to do in KVM with like defining an XML file with that, the name of the network, and then we had to add a interface on inside of VM into that network. This is just going to take care of it for you automatically. And so that's all it is to add devices. If you want to power them on, just right click and click start. There's also a wipe functionality, which I use a lot. This is saying, hey, power down the virtual machine and then restore it back to the golden image of this specific device. So forget about any config that's on the box, forget about any of these other types of functionalities, just go ahead and wipe it. We're going to start from scratch. I actually use that more than I would care to admit. But in my case, I'm going to close out this lab topology and I'm going to go back to the one that I had running. And Eve provides a really quick shortcut for you to identify what those are. I'm going to click on this directory that's automatically there for you called running. In this case, I'm going to select the 001 demo. And then I can get kind of like a snapshot of what this lab actually looks like. So this is a lab that I'm going to be working from for the next few minutes. It's got a couple.
Hey, Calvin, are you there?
Yep, still here.
Hey, this is Brian. So we're in a tornado warning right here where I'm at. So I asked about if nested virtualization and promiscuous mode were required for running in ESXi.
Good point. So coming back over into ESXi, first of all, please be safe. Holy moly, living in Texas, I know how bad those things are. There are some instances on the virtual distribution switch where you'll need to enable promiscuous mode to enable some kind of connectivity between the VMs. And so like what that would actually look like in this case, let's look at the virtual SRX fabric. This is a port group that I have on this virtual distribution switch. It's got 2 VMs inside of here. You'd go to your edit settings and make sure under advanced or security, you enable promiscuous mode. This will allow the VM to VM communication to take place. A super important point if you're doing any of the Juniper appliances that have a separate routing engine, a separate forwarding engine, this one thing will prevent those two from building a relationship with each other if it's set to the default of reject. So yes, absolutely. That's something I do all the time on every VMware distributed switch port group that I create is I enable promiscuous mode for sure. That helps those relationships come up there. You also want to use VLANs if you're doing those types of communications, because you want to keep those networks clean, right? You only want that type of communication to go over. So hopefully that helps answer the question. Sorry, I missed that one.
No problem. We're huddled in the basement, so if I drop off, the content is great. Thanks for covering.
Holy moly, man, you got me scared. Good luck to you, brother. Please stay safe. And all
Thanks
these
again.
are uploaded to YouTube, so don't worry. Like, by no means hanging out with me is not the most important thing right now. Back into the to the Eve NG side of things, I've got a couple of virtual firewalls and some containers that are connected as virtual machine or connected as hosts onto these. And so if I click into this device right here, what I'm going to get is a VNC console into this Docker container. Let's click on it. You can see it's embedded within my desktop web browser, so I don't need to do like install any kind of VNC software or anything like that. It's just right here within my browser. And if I ping my default gateway, which will be my firewall, see 1.1, here we can see that I've got a direct access into it. And if I just look at my route table, I can see my default gateway is pointing to 1.1. And the virtual firewalls, again, same kind of idea. You're going to get an embedded console here within your browser. You can have it use like your iTerm or secure CRT, although I will admit it's a little bit more difficult to get like things like secure CRT working on a Mac computer with the integration into Eve NG. It's not as smooth and intuitive as I like. It'll open up like a separate instance of a secure CRT for every device rather than using tabs. And that kind of drives me a little bit crazy. You can also push the console to a dedicated web browser tab as well by clicking that little arrow. And it's going to use Guacamole behind the scenes to perform that VNC connection. And so I've got this network topology, but I got a problem in that I don't have a connection in between here. So what I'd like to do with you is show you how to add a new virtual appliance into Eve NG, because it's quite a process if you're unfamiliar with the order of operations. So what we're going to do is we're going to use the virtual MX that I had downloaded, the KVM version of it earlier. It's on my computer's desktop. I'm going to show you how to get the image over to the Eve server, how to get it into the right directories, and then we'll see it listed here within our topology. Now, if I right click and say add a new node, and I select the virtual MX, let me unclick that. If I select the virtual MX, you can see I've already got one right now for both the routing engine and for the forwarding engine. For the routing engine, though, the image version is 19.4R3, and I want to live on the bleeding edge. Hey, this is my lab. I can get away with these types of things. So what I'm going to do is I'm going to install the latest version, which is like 21.2 or something like that, and you will see it come up here once we're all done as an option for us to add to our topology. So I'm going to bust out my Linux terminal or my Mac terminal here, and I'm going to look on my desktop for a file that is, let's just look here, VMX bundle. All right, so I have a bundle that I downloaded from the juniper.net website. What I need to do is I need to get it onto my Eve NG server. Now, Eve is running Linux, so I can do things like secure copy over to it. So let's just go ahead and secure copy my image bundle that we downloaded. and I need to use the root user on my Eve server. Now I'm using DNS, so I can get away with using a host name, but if you don't have DNS, you would point in the IP address at this point. But really important, if you don't use secure copy every day, you need to know after you type in the name of the host or its IP address, add a colon, and then add the path that you want the files to be copied to. So in my case, I'm going to say /var/temp and hit enter, and it's going to ask me for my super secret password. And now it's going to use SSH to copy the image off of my workstation over into EVE-NG. Now, while that's going, let me show you how to find the documentation on how to do this, because we will be referencing it at Juniper VMX EVE-NG. And EVE-NG is the maintainers, they're not native English speakers, so sometimes the documentation, the phrasing is a little janky. Don't worry about it. It's okay. You can figure your way out through it. But if you are, just don't be a grammar Nazi in this case, right? Just give them a little break. So in this case, looks like they're using virtual VMX version 17.1. That's going to be fine. What's really important for us, though, is we understand kind of the order of operations. What they're telling us here is that versions are often very old, but you can create your own custom images. Yes, absolutely the case. Thank you. So what they're telling us here is that we need to create a temporary working directory. This is where we're going to unzip all of our files that came into that tar file that we downloaded. And when we unzip it, we're going to get a plethora of different images within that VMX bundle. Now, we only need to copy over a couple of them. This is arguably the most difficult device inside of EVE-NG. So I want to just use this as an example because everything else is easier from here on out. But you're going to have to dust off some basic Linux administration. So if this is something that doesn't come naturally, please always reference the documentation. It's really important that you know that in EVE-NG, when you create the directory for your virtual machines, they're expecting a very specific path, and they're expecting a very specific naming convention for these virtual machines. And the version that you place as like the identifier, it's going to be literally screen scraped on the EVE side. They will use that to determine what's the version of the image whenever you're importing it, like we showed here when we selected the virtual machine. This, come on, buddy. This right here was all determined based on the folder directory that you create on the host itself. So there is some importance into getting it right. Let me go ahead and jump over into that EVE server. So SSH root at EVE in my case. Again, you need to be using the root user, which is kind of weird on Ubuntu because they typically ask you to not use the root user on Ubuntu, but whatever. All right, in our case, the EVE path where most of all the images go is going to be in /opt unet lab. Just so you know, EVE-NG used to be, or is an iteration on a former product called unet lab. They no longer call it that. It's called EVE. It's its own product now. We're going to say add-ons and QEMU. Now, if I do an LL on here, I can see all of those images that I had listed before within the EVE topology. Well, guess what? They're now here as well. So what we're going to do, we'll go ahead and follow the instructions. I think they said create a directory called ABC. So I'm just going to say make dir ABC. And I'm going to change into the ABC directory. Now, I know that the image or the bundle that we downloaded has successfully completed its secure copy. We remember we placed that in the /var/temp directory on this host whenever we did the secure copy. So I'm going to copy, actually, I'm going to move var temp and then VMX bundle. I'm going to move that into my current working directory. And the way that you point to your current working directory in Linux, just say dot and then the / and it'll say, oh, you mean your current working directory. And now if I type in LL again, I can see that I've got one file in my ABC directory. It's the VMX bundle. in order to unzip a tar file, it's tar ZXVF. I know that off of muscle memory. I would never be able to tell you on a game show what the command actually is. I know it with my fingers. So tar ZXVF for unzipping. And if you want to compress files, it's tar CVF to do that. So anyway, we'll go ahead and uncompress this tar file. You'll see all the images that are available here within our directory. As that goes through, let's go ahead and reference the documentation yet again. Oops. Control-Shift-T, get that back up. There we go. So it says now we need to create a directory to hold the routing engine. So I'm going to go ahead and copy this line and jump back over into my machine here. And I'm going to paste it and regret life because what I really meant to do was edit this. So say 21 dot, I don't remember what's the version that we're running with here. A lot of files got unzipped. 21.2 R1. We'll just say that's fine. So I'm going to make a directory. Oops. I'm making directories all over the place. Hold on. Let's back out here. ls-l, and let me remove this one. Remove this directory, please. rm-rf. All right, so now let's go ahead and make that directory. We're going to say vmx vcp 21.2, and that's fine. That's all I really care about. That's good enough for me. And then we're going to make another one for the forwarding engine. So the forwarding engine's name is supposed to be VFP. So the only thing that's different between the folder directory name is C for the control plane, F for the forwarding engine. So I'll hit the up arrow and say VFP. All right, clear my screen and I'll say ll grep VMX. All right, it looks like for VMX, I have a couple of directories here for the 21.2 goodies, okay? And all of our binaries are still extracted in the ABC directory. It's now gonna be our task to move the important ones into the directories that we just created. So as you can see, even G, as great as it is, it definitely has an expectation that you need to be able to do some basic Linux administration, moving files around, copying files, renaming files. There's definitely some room for improvement as far as a user experience, like what GNS3 has or with Vagrant has, where it kind of simplifies this image upload process. On ours, we just got to roll up our sleeves and get down to it. All right, the first image I'm going to grab is something that starts with Junos-VMX. All right, let's look for that in my ABC directory. Junos images, VMX images, Junos, there we go. All right, so that's the file that I need to move. Now, what's interesting is that just like I did on the KVM side, where I said I don't want this name because that's difficult to remember, even G is kind of in the same boat. It's expecting you to name these images in a very specific format. If you get it wrong, guess what? Your virtual machine is not going to boot up. You'll get a black screen whenever you power on the VM. And so you need to make sure that you follow the instructions pretty well. In this case, this machine is supposed to be named VirtIO-A inside of my control plane folder. So we'll say copy, actually, we'll just move it, move ABC, VMX, images, Junos, and we're going to put this into VMX VCP 21.2, and I'm going to name it, let's try that again, VMX VCP 21.2 VirtIO-A.qcal2. So that one's done. Let's go ahead and now pick our next image, which is VMXHDD.img. So we'll move ABC VMX images. What was it again? VMX HD. There we go. And we're going to name it VMX VCP 21.2. And this one's going to be called VirtIO-B.qcal2. So really interesting point. You're seeing us rename a file extension with .img into a different disk format called QCal2. I mentioned this earlier when we were talking about KVM. It doesn't really matter. You can do this on with KVM disk files. It's not like you download an MP3 and then change the file extension to a JPEG. It's not going to work, but it will work in the context here of virtual disks. All right, and the last one for the routing engine is called metadata USB RE image. So we'll find that one, VMX images, and I already forgot the name, metadata USB RE, what is it, re.img? It is. All right, and we're gonna name that one virtioc.qcal2. All right, so VMX VCP 21, come on, buddy. And then virtioc.qcal2. All right, and if I look into my directory for my VMX VCP, I'll see that I've got 3 disks, virtio A, B, and C, that maps to the 3 disks that we just moved. Now, I also want to do the forwarding engine, but luckily for us, that one is super simple. There's just a single disk that we need to move. So it's going to be called VFPC. So move ABC VMX images VFPC, and we're going to move that into our VMX VFP 21.2, and they want that named virtioa.qcal2. All right, now I've got my images and they're named correctly, and then they're in the correct directory. There's one step left that you need to do in EvenG before these actually show up. And that is you effectively need to update the permissions on the disk files. So the way that we do that, excuse me, is we run a command that I will never remember. It's in a directory that I will never remember. So let me do history grep wrapper, not like 50 cent or anything, but this is the command that you have to run. Opt unet lab wrappers unl underscore wrapper dash a fixed permissions. You can see I run this command quite a bit because every time you add a VM, you need to run this before Eve has the correct permissions to access that virtual machine. Yeah, seriously, Zach, definitely time to write a shortcut. Interestingly enough, this itself is a shortcut. I think we can actually look at the script itself. I don't think it's compiled. But what you'll get is you'll get first Eve, the pro version will check to make sure that your license is valid. Let's see if I can't look into that wrapper. Okay, so they hashed it on me, so they're not going to let me see the goodies that they're actually doing on that wrapper command. Don't worry about what I just did. Oops, let me clear the screen here. All right, now if we go back to our topology, I should now see a virtual MX for a routing engine and forwarding engine all running the bleeding edge goodies. So let's go to the menu, select the VCP, and look at that. We already see 21.2 listed. I'm going to call this, we'll call it WAN router 1. And I can select the icon. I want the icon to be an MX router. I can select the resources, but it's pretty confident that it knows the right thing for us. So I'll add that. The topology will refresh. If you understand Junos architecture, you know, again, we separate the forwarding engine and the routing engine. So now I need to add the forwarding engine. So we'll add the VFP, and I'll select the 21.2 version of that and click save. And now we can finally build our connections in between our sites with this kind of monkey in the middle being a new virtual MX. So we'll hover and drag a link over there. We'll say on virtual SRX1, it'll be gigabit 000, and it'll connect to 000 on my router forwarding engine. And we'll do the same thing on virtual firewall 2, except the data interface that it's going to use is going to be just a little bit different. As you can see, there's a little bit of lag within the response. The HTML5 can really do some amazing things, but sometimes the performance isn't the best. We'll go ahead and select gigabit 001 on this side. And then I need to build the connection between my forwarding engine and my routing engine so that the virtual machine actually comes up and we can build that control plane adjacency. And so I'll do that right here. All right, so we're running low on time. I do want to point out some other things because we've only done the VMs thus far. I talked a little bit earlier that the one that I'm really excited about is containerization. And I did mention earlier that EVE-NG actually supports containers as well. So let me show you what that looks like. I've got another lab currently running. It's this, let's go back to our running, and then I'll pick my Redtail MPLS network and I'll click the open button here. And what this will show is that we've got, holy moly, a lot of routers running right now as containers inside of my lab. So this is a lab that I'm using to do some of my security or service provider certifications. By itself, it looks really ugly because every one of my devices has a connection to this out-of-band network. So it makes it pretty difficult to understand kind of what link is connected to what. It kind of gets a little bit complicated. Thankfully for EVE, they have this construct of a logical map. And I highly, highly, highly recommend that you use this. So you can build out a network topology in something like Visio. And then you can use the construct of a virtual logical map. And then you basically map out the connections themselves, right? And then this Visio topology now becomes an active lab that you can click on any of the devices and get direct access into the router itself. So the benefits of running CRPD is that instead of like requiring, you know, X amount of gigs of RAM, X amount of CPUs, et cetera, CRPD from Juniper runs extremely minimal. Like this entire topology that you're seeing, I don't remember how many routers. Let's just say it's 16 routers. It requires less than 1 CPU on my device and about 2 gigs of RAM to run all of these routers in an MPLS network environment. It's just unparalleled performance benefits to running things in containerized world. However, there are some quirks that I mentioned. Remember, in the containerized world, it has no access into the infrastructure components. So in the containerized world, the physical interfaces on the host are exposed to the container with the same name. So instead of like gigabit 000 or something along those lines, it's literally Ethernet 0, right? Or to show you even a stranger one, it's like let's see, protocols. Let's actually see if I can exit out of the shell. So here I'm in the actual Linux bash for this container. If I type in IP link show, I can see the IP interfaces on this container. So loopback 0 is just called LO. That takes some getting used to. And then, yeah, you have all your Ethernet interfaces as well. But again, unparalleled performance benefits to doing something like this. Just know that there are some quirks with it. EVE-NG fully supports containers. They're quite easy to add. There's some pretty decent documentation in the EVE-NG cookbook that you can find on their website. So here's the professional cookbook. If you're interested in figuring out how to upload like a containerized SRX or containerized RPD, this is the place to go for that. Looks like my internet's failing on me, so I'll just curb that one for this side. The last thing that I have time to showcase today is another containerized network solution that was built by our friends over at Nokia. It's called Container Lab. Let's see if I can figure out my IP address. Oh, there we go. Get the right username here. Ubuntu 20 Container Lab 1. All right. Okay, so Container Lab is exactly what it sounds like. It is a multi-vendor network topology generator that handles all the containerization for you. And what really helps, or what really makes it very attractive, is that it's completely based on a YAML file. So you can have like kind of like an infrastructure as code, which helps you codify your network topologies, helps you spin up and spin down these topologies as well. So let's give you a little bit of an example as to what that actually looks like. I've got a couple directories here. One of them is called Container Lab. Let's go into that. And inside of here, I've got one for CBT Nuggets, which, by the way, if you didn't know, they have some of the best Juniper training on that website. Highly recommend them. Let's go ahead and look into that directory right here, CBT Nuggets, and looks like I've got a single lab right here called 001. Let's go ahead and create a new lab. I'm going to call it 002. It doesn't have to be this. It can be, we'll give Zach a little bit of limelight again. We're going to create another Zach directory here. This will be an empty directory. Now we want to build a full spine leaf topology and have all the containers connected to each other. So all the connection points that we had to do in EVE-NG, where we're like dragging lines between them, CRPD will actually handle all of that for you, or you can customize it yourself. So in my case, I'm going to say sudo container lab generate, because I'm going to generate a new lab environment. We're going to call this, we'll call it Zach Lab, and then we'll go ahead and specify how many nodes I want on here. So we're going to do 4 at the leaf layer, 2 at the spine, and 1 at the top. The kind, so there's, you can actually run virtual machines inside of Container Lab as well. Or you can do, multi-vendor network OSs that are also containerized as well. So in my case, I'm going to say the kind is CRPD. The image version is going to be CRPD equals CRPD 21.2 R1.10. I think that's right. And we're going to output this file in a new lab. We'll call it lab.yaml. All right, so that didn't really provide a whole lot of whiz bang. Just know that a file was created called lab.yaml, and it basically created a network topology diagram based on the parameters that I had passed it, right? And so it built all the connections in between the devices. It also specifies what kind of device it is. And let me make sure that this is the right image. So let me exit out here and say Docker images and grep for this. It doesn't look like it was. Docker images. CRPD, nope, it looks like that's going to be right. 21.2 R1.10. All right, good to go. Now, in order to build this lab, hey, let me come here. In order to build the lab, or to actually kick it off, we're going to say sudo container lab, and we're going to say deploy, and I'm going to point to my lab file that we just pointed to. Now, before I do this, let's go ahead and just check out any current running Docker containers. It looks like I've got a few running here right now. So we're just going to add a little bit more. We're going to say, again, sudo container lab and deploy, point to our lab file. And it's going to go ahead and build separate containers for every single one of our routers, and then build all the connections in between those, and then provide you with the name of those containers, as well as their management IP addresses for both IPv4 and IPv6. And it'll tell you what kind of group that they're associated if you build out like multi-layer, multi-tiered environments like a spine leaf data center or something along those lines. Now, all you need to do to access this is the typical Docker commands, Docker exec, IT, the name of the container, and we'll say CLI to give us the Juno CLI. And you'll see that we're already in the device as well. Now, the basic configuration that comes with it, it's probably the smallest you'll ever see. It's just a root authentication password. You're going to have to actually build the configuration yourself by scratch, but fear thee not, it's standard Junos goodies, right? So you shouldn't have any problems getting off the ground and running with this type of stuff. So the same also is true for containerized SRX. The same is true for virtual machines as well. If you're interested in Container Lab, again, completely free solution. Container Lab, there we go. This is a really recent technology. It just came out, I think in April of this year. You can see they have pretty good support here. It can run not just containers, but as you can see here, also virtual machines as well. So if you would rather have a method of spinning up a lab that's based on like a YAML file that defines the actual definition of your lab rather than a GUI where you're clicking and dragging and moving things all over the place, then I highly recommend checking out Container Lab because it's a gosh darn pretty amazing piece of software, I do say. With that being said, hey everyone, we've just got a couple minutes. Does anyone else have any questions or like any kind of clarification before we wrap up? All right, I feel like the Micro Machines guy. I've been talking at 200 miles an hour, so I'm gonna take a break. I'm glad it is helpful for you all. I'll go ahead and upload this up to the YouTube channel so that you guys can kind of review it. I'd be really interesting if you share with us, which solution that you pick and any of the reasons why, if you're going with VMs, if you're going with containers, if you're, ponying up the money to use EVE-NG Professional. Just be really curious as to some of your motivations and what it is that you actually run with. But with that, someone over here is married to EVE-NG. So with that, again, thanks everybody. Appreciate you coming out here. We'll be returning into the automation space next month where we're going to be doing some Python deep dives with some of the network automation capabilities that we provide. And until then, enjoy the rest of your summer, y'all. We'll see you in about 4 weeks. Have a good day.